A soccer ball can curve through the air with zero spin at all. And that's the part that should terrify every goalkeeper on the planet. Here's the wild thing. Curling a free kick with spin? That's easy physics. Coaches have understood that for decades. But a knuckleball free kick, the ball that seems to wobble, dip, and change direction mid-flight like it's got a mind of its own, that's a completely different beast. It breaks the rules goalkeepers spend their whole careers learning. So how does a ball with almost no spin become the most unpredictable object in sports? Stick around. By the end of this video, you'll never watch a free kick the same way again. The setup. Let's start simple. When a player hits a knuckleball, they're not trying to curve it. In theory, curving a ball is about spin. Spin creates a predictable arc. Predictable is bad for the guy trying to score. So instead, the striker strikes the ball almost dead center, with barely any rotation. Cristiano Ronaldo made this famous. So did Juninho Pernambucano before him. The ball comes off the foot looking calm, almost lazy. Don't be fooled. That calmness is the whole trick. Why spin usually helps. Here's where it gets interesting. Normally, spin is your friend. When a ball spins, it drags a thin layer of air around with it. That layer creates something called the Magnus effect. It's the same reason curveballs curve in baseball. Basically, spin makes the airflow around the ball predictable. Predictable air means a smooth, curved path. Goalkeepers can read that. They've seen 1,000 curved shots. Their brains do the math without even trying. Take away the spin, though, and you take away that predictability. And that's exactly what a knuckleball does. The seams are the secret. This sounds simple. It isn't. A soccer ball isn't a smooth sphere. It's covered in seams, panels, and tiny surface bumps. When there's no spin to stabilize things, the air hitting those seams behaves erratically. Picture a fast river hitting a bunch of random rocks. The water doesn't flow in one clean line. It swirls, breaks apart, and shifts unpredictably. That's basically what's happening to the air around a knuckleball. Since the ball isn't spinning, those chaotic air pockets don't average out. They just sit there, randomly, changing, mid-flight. Turbulence is the villain. Here's the science part, but don't worry, I'll keep it easy. As air flows around the ball, it separates unevenly on different sides. One side might have smooth airflow. The other side might have turbulent, chaotic airflow. That imbalance creates pressure differences, and pressure differences push the ball sideways, up, or down randomly, and sometimes more than once during the same shot. In practice, this means the ball can appear to be flying straight, then suddenly dip or veer at the last second. It's not magic, it's just air behaving badly. Speed is the trigger. You'd think slower is safer for a knuckleball. No, the wobble effect actually depends on hitting a very specific speed window. Too fast, and the airflow becomes too chaotic to create a clean knuckle effect. Too slow, and the ball stabilizes too much. Elite players are basically threading a needle. They need just enough power to keep the ball moving fast, but not so much that they lose that unstable, seam-driven wobble. This is why knuckleball free kicks are rare. Most players can't consistently hit that speed and spin combo. You know the type, the ones who try it in training 100 times and only pull it off twice. Why goalkeepers hate it. Let's talk about the poor guy standing between the posts. Goalkeepers train their brains to predict trajectory using two main clues, spin and speed. Take spin away, and the ball's path becomes almost impossible to forecast. The keeper sees the ball leave the foot, calculates an expected path, and then the ball ignores physics as they know it and drifts somewhere else entirely. This is why you'll see world-class goalkeepers dive the wrong way, freeze completely, or make those weird last-second adjustments. It's not bad goalkeeping, it's the ball cheating the system. Why it actually matters. Here's the payoff. This isn't just cool trivia. Understanding knuckleball physics has actually influenced how soccer balls are designed. Manufacturers now study seam patterns and panel counts specifically to control, or sometimes increase, this unpredictable wobble effect. Some balls are designed to be more knuckle-friendly. Others are built to reduce the effect for fairness in professional play. Yeah, ball design is basically a chess match against unpredictable air currents. Wild, right? Wrapping it up. So let's loop back to where we started. A ball with almost no spin becomes the most unpredictable object on a soccer field purely because of turbulence, seams, and a very narrow speed window that only elite players can consistently hit. In one sentence, the knuckleball free kick isn't magic, it's chaos, precisely engineered. So next time you see a player line up a free kick and barely seem to swing their leg, don't relax. That calm approach might be the most dangerous shot on the field. Do you think more players should be practicing this shot, or is it too unreliable to rely on in big moments? If this kind of breakdown is your thing, subscribe. I break down the science behind sports in a way that actually makes sense, and trust me, there's a lot more where this came from.